So there I am, where I go. So we're trying to figure out what the slope of the line tangent to the polar curve r equals 2 cosine theta minus 1 is, where theta equals pi. So when we're looking for the slope of the tangent line to whatever that graph looks like, we're looking for dy dx. So the problem here is everything's in polar coordinates, so we're going to have to change that. So dy dx we know is dy d theta over dx d theta. So let's figure out what y is and take the derivative with respect to theta for the top. And let's figure out what x is and take the derivative of that with respect to theta on the bottom. So for a polar graph, y is always equal to r sine theta. So in this instance, r is 2 cosine theta minus 1. So y is 2 cosine theta minus 1 times sine theta. So we're going to have to figure out what dy d theta is, so let's do it. Dy d theta, that would be the top of this fraction for dy dx. It's a product, so it's the first times the derivative of the second. Derivative of sine is cosine. Plus the second, which is sine theta, times derivative of the first, which is derivative of cosine is negative sine, so this is going to be plus negative 2 sine theta, derivative of 1 is 0, times sine theta. So that was just the product rule of this. Let's not simplify it all because we're doing it at a specific point. So let's do the denominator dx d theta. So I'm going to change, let's go. We know x is equal to r cosine theta. So x equals r 2 cosine theta minus 1 times cosine theta. I'm going to do this one a little bit differently. You do not need to do this. You could just use the product rule right now to get dy dx. Since I have 2 cosines here, I'm going to distribute that cosine and use the chain rule here instead. It's completely up to you. I just want to do it differently. So dx d theta, the denominator of this, will be just the derivative here. So chain rule, we have cosine squared, so it's 4 cosine to the first times the derivative of the inside, which is the derivative of sine, which is negative sine. So I'm done with that, the first term, and then times the derivative of cosine, which is negative sine, so this would be plus sine. So now I can make my whole dy dx, put dy d theta up top, divided by dy dx d theta on the bottom, and plug in 3. Or you can just plug in 3 to the top and the bottom, which I'm going to do now. And then just put whatever I get here at theta equals pi. Whatever I get here divided by whatever I get here. So let's start with the dy d theta. If you plug in pi, you will get cosine of pi is negative 1. So I have negative 2 minus 1. So I'm plugging in pi here times negative 1 plus sine of pi is 0. That's nice. So it's negative 3 times 1, which is 3. So dy dx is at pi is 3 over. Now we have to figure out dx d theta at pi. So we have 4 times the cosine of pi times the sine of pi. We already said the sine of pi is 0, so good. That's 0. Plus, again, we already said the sine of pi is 0, so that's 0. Good. So dx d theta is 0. So that's the derivative. And since your derivative turns out to be 3 divided by 0, that the slope of the tangent line here is undefined. So good problem. That's how you find dy dx for polar graphs.